Cool. Right, we're going to hear about web transport and web codecs. Yes. So really cool hot topics at the moment on kind of where media in the browser is going, whether or not WebRTC joins it in the future, like carries on joining it. So take it away. I'm really looking forward to hearing about web transport and web codecs.
Okay. Hello, everyone. My name is Manish Kumar Pandit, and I'm from India. I work in Diet as a software engineer, and mostly I like to work on RTC and stuff, and on the weekends I practice my flute. So yeah, that's me. Now, so you can see in the screen that there is some live streaming going on or video calling. So most of the people know that we can do video calling on the browser using WebRTC. But for those who doesn't know about WebRTC much, I would want to talk about it in very brief. So WebRTC is basically a technology that provides browser to capture and share audio and video along with some arbitrary data exchange between two browsers directly without using any third-party integration or third-party tools or anything. So some advantages of that are you can build real-time application without needing any additional plugins or tools, which simplifies the development. It also provides direct access to the peer connection object that you get in the browser, allowing the real-time communication. And the browser, the WebRTC inbuilt support turn and turn protocol to work with the NAT environments, right? It uses UDP because it's fast. Also, there is a way to configure WebRTC by using HDP, and yeah. So basically, it also has end-to-end encryption inbuilt in that. So these are some advantages of WebRTC. So I think this seems pretty cool, but there are some cons associated with it. I won't say it's a cons, but some limitation, I would say. And we can do much more with the new technologies available, like Web Codecs and WebTransport nowadays. So let's see what limitations or what area, few things lack WebRTC, which Web Codecs and WebTransport can handle. So few things it's very high-level API, peer connection. You get some APIs, and there is not very much configuration it provides. Also, the configuration management happens via HDP, which can be cumbersome. The connection setup process is also a bit slow and complex. There is a tight coupling of get user media and the codec. That's the one thing, and which limits the encoding controls. Also, different browsers have different, not different implementation, but slightly different implementation. Like Firefox maintains their own fork of libWebRTC, something like that. So yeah, these are some things that where WebRTC stay behind. So how does Web Codecs and WebTransport handle that? We are going to talk about that. So yeah, the main talk, Web Codecs and WebTransport. So first, let's talk about Web Codecs. Web Codecs is a powerful technology that gives developer more granular control over media encoding and decoding. Unlike WebRTC, which abstracts this process, and Web Codecs allows for direct access to codecs, enabling more efficient and optimized media handling. This is specifically useful for applications where you want high performance and more control how you want to process the media in the browser, right? So with this, the developers can fine-tune their encoding parameters. They can achieve better quality, low latency, hardware acceleration, things like that. So yeah, now Web Codecs provides two things basically. We only care about two things mostly: encodings and decoding. So Web Codecs provides encoders. encoders in web codecs are designed to convert raw media that you capture from like media stream track or canvas into a compressed format, making it ready to like easier to transmit over the network, right? Or if you want to store, you can store it. So web codecs like customize. This provides the customized encoding thing. So like this gives the direct control, which helps in optimizing performance. Like, so if you want to use multiple codecs, like if you want to use VP8, Opus, H.264, they provides, right? Also, they have audio encoders like Opus, like just I said. That is like covering most of the codecs that we use in our like in real life mostly. So yeah, developers can also set specific bit rates, heights, video height, video width, and resolution and quality levels. Okay. Now, so yeah, that's the thing. The Web Codecs API is also designed to like they gives option to select like you want a real-time video or like you want to optimize latency or you want to do a real-time or something like that. So yeah, that's about encoders. So if you see the flow in the screen, you can see that we can capture the video frame. I'm specifically talking about video only right now. So we can capture the raw video payload from canvas or media stream track, and then we pass that frame to video encoders. Also, video encoders are configured with the config where like just I said that about the video width, height, and some information. So video encoders encodes that video, and it provides a simple video frame, encoded video frame actually. And once a encoded video frame is ready, you can like store it or you can transfer it over the network. Cool. So this is how encoding works in the browsers using web codecs. Now, once we have compressed chunks, to use it or to playback it, we have to decode it, right? So web codecs also provides a decoder. So decoder in web codecs are basically used for decoding purpose as by name. So how does the decoder work is like this. So you get the encoded frame or chunk from the network or the storage file anywhere, and you first configure the video decoder because previously you have encoded a video frame with some specific configuration like the video codec and the height and width and some things like that, right? So you just pass that, you configure the video decoder with that information, and then you just pass the encoded video chunk to video decoder's decode function. And that will take care of decoding the chunk to a video frame, okay? And yeah, once you get the video frame, you can pass it to canvas, or like you can paint it to canvas, or you can pass it to media stream track generator kind of thing, right? So as we know, like web codecs provides encoding and decoding both, but the problem is with the transfer of encoded packet or the encoded frame. So how do we do that? So we have WebTransport in the browser, right? WebTransport is an advanced API designed to facilitate low latency bidirectional data transfer over HTTP3. It provides powerful alternative to traditional methods like WebSockets, offering both reliable and unreliable options. This makes it ideal for applications like applications requiring high performance and low latency, such as real-time video streaming and online gaming, things like that. So a few key features of WebRTC is like low latency communication. They also provide reliability options like reliable and unreliable datagrams. Also, web transports are bidirectional and unidirectional both, like they have this feature of bidirectional and unidirectional stream. They also handles the congestion and network changes by themselves. So yeah, these are the few features that web transports give you. Now, basically, web transport can give you these features by using the capability of HTTP3 and QUIC. So let's talk about HTTP3 and QUIC a bit. So most of the people know about HTTP2. HTTP3 is the latest iteration of HTTP protocol, designed to enhance the web performance and reliability. Unlike previous version, HTTP3 uses QUIC as its transport layer instead of TCP. QUIC is a short form of Quick UDP internet connection, which is developed by Google and which runs over UDP. So this combination brings several key benefits of web communication, and these are reduced latency because you see TLS is integrated into the transport layer itself instead of being at a different layer. Also, they provide stream multiplexing. So stream multiplexing was in HTTP2 also, but it is inbuilt provided by QUIC now. Also, the improved performance because of it uses UDP. Also, it has better network transition in with very low number of 0 or 1 RTT network migration is there. Also, there is transport extensibility using extension, right? So QUIC also support unreliable transmission via datagrams. This is very fast and out of delivery feature, which is beneficial for where you don't want the reliability of the data you are sending. You just want it to be received on the other end very fast, right? So yeah, a little bit of protocol stack of HTTP2 versus HTTP3. In the screen, you can see I have taken the image from the link, and you can see the layers, right? So there is application layers where not much changes, but now one thing that is moved to QUIC is stream multiplexing, because now it's on the transport layer. Also, you can see the security is inbuilt into the transport layer. So basically, you can see most of things have been moved to transport layer because HTTP3 uses QUIC only. So all the features are coming from QUIC mostly. So yeah, that's that. A small overview on the handshake of QUIC as compared to TCP and TLS. So basically, you can see QUIC client initiate a connection with a single packet that includes the initial encryption setup. The server responds with a packet that completes the handshake and confirms the encryption keys. This streamlined process allows encrypted communication to start immediately, reducing latency significantly, right? So for subsequent connection, QUIC can quickly resume session using session tickets, minimizing the need for full handshake. Now, in TCP with TLS 1.2 handshake, HTTP or HTTP2 kind of setup. In contrast, there establishing a secure connection is involving more steps. So first, TCP is three-way handshake, set up the connection, then an additional handshake negotiate the encryption keys, and establish a secure TLS connection. This requires several back and forth messages, increasing the time and latency before secure communication can begin. So yeah, resuming a TLS session over TCP is quicker than initial handshake, but still involves more steps compared to QUIC's streamlined process. Now, come back to Web Transport's API. Basically, browser provides us 4 main APIs. These are Web Transport bidirectional stream, datagram duplex stream, receive stream, and send stream. They are pretty self-explanatory by the name. So the first one is they can send and receive data on the stream. another one is specifically for datagram. The last two are for receiving stream only and sending stream only. So yeah, basically that was all about the talk. So I have prepared a small demo that I want to show you. Just a second. Okay.
Change it back to mirroring mode first.
So which?
You want to shut mirror, yes?
No, I will open a tab there only. No issues. Yeah. So I can. Yeah. Cool. So I am running a local server. Actually, all things are running in my local right now. So let's see what's happening. You can see all the errors here as well. Cool. So first we can acquire video. You can see me. Hello. Cool. Then I can connect the transport. So web transport is now connected. Now what we want to do, we want to initialize the encoder, where encoder is initialized. And now we want to initialize the decoder. This is very simple echo server kind of setup, where you send the packet and you receive the packet in the same server, or you can do this on the other tab as well, but I'm just showing in the same tab. So yeah, cool. So this is how it's working. And yeah, the packets are going from my local machine to server to then come back to my local machine. And some very basic stats that I don't think that makes much sense here. So yeah, this was that. Cool. It's done. Okay. Oh, sorry. Great. Yeah, we can take questions. Yeah.